you have a 10K at the input along with the voltage source, and you have the feedback between the 2 and 6 terminals of the op amp, a 100K resistor, and at the 3 input it is grounded through a 10K resistor. This is meant to balance it, actually to take care of the differences in the input bias current, about which we will discuss at a later time. So I have put a 10K resistor which is almost the parallel value of 10K and 100K, it is about 9K, so I have put the nearest value 10K here. Now this is the output voltmeter. Here this is the op amp, you can see the 7 is connected to the rail voltage, which is connected to plus 15, and the bottom black is the ground and the green is the minus 15 volts, and you have the 2 resistors, the 10K and the 100K resistors connected in the feedback, and there is a 10K resistor which is coming from the pin number 3. So this is a voltmeter, it is measuring volts, and this is a voltage source which you have seen in the earlier experiment. So I can change the dials and change from millivolts to volts, and that is connected to the input of the amplifier between the terminal 2 of the resistor that I have between this point and the ground. That is what I have connected here. This voltmeter measures in parallel. I have connected the voltmeter in parallel to that voltage source, so that I know whenever I change the voltage I will measure what is the voltage I am applying at the input. At the output I have connected this voltmeter, which is again a multimeter in the voltage range. Now I have got here 100 millivolts, so 100 millivolts. So the gain is 100K divided by 10K, that means 10 times. So I have, it is actually 10 millivolt. 10 millivolt, I will come to a lower range, then it will be better. So I have kept it here in 2 position, that means 20 millivolts I am applying. So the reading here is 0.02, 0.02 volts, this is in volts range. 0.02 means 20 millivolts. If you multiply by 1000 you will get it in millivolts. 0.02, if you multiply 1000 it is 20 millivolts. So I have 20 millivolts multiplied by 10 should be 200 millivolts, and what I get in this power supply is 0.20 volts, that means 200 millivolts. So 20 millivolts, you can see 0.02 is coming as 0.2 multiplied by 10 times. If I put 0.3 here, 30 millivolts, you get 0.3 volts at the output correspondingly. If I make it 40 millivolts, you can see again it becomes 0.04, and the output voltage is 40 millivolt for 400 millivolt or 0.4 volts. Now if I keep on doing it, now what I will do is I will increase it in hundreds. Now I increase to 100, so now it is in 2 position, that means 200 millivolts, that is shown as 0.19 or 0.2, right. So this is 0.2 means 200 millivolts multiplied by 10 should be 2 volts, that is why 1.95 you are getting. Now if I change it to 300 millivolts I get 3 volts nearly. If I change it to 400 millivolt I get nearly 4 volts or 3.89. The difference, as you can see, is because the resistors are not precise. If I take 1% resistors and try the 100K, 10K, etc., you would find very close to the exact number that you think. Now if I keep on doing it, you might ask what will happen if I go to very high values. For example, now I apply 900 millivolt, you can see that 0.987 multiplied by 10 is 8.7. Now what I am going to do, 8 volts I am getting, I will increase this still further to 1 volt at the input. So I have 1 volt here, so you have 0.97 volts here, this is 1 volt correspondingly 0.97 volts. So multiplied by 10 is 9.7 volts, that is what you are getting. Now if I put here 2 volts, what will you get at the output? Obviously you will say 2 into 10 should be 20 volts. Let us see whether we get 20 volts. I have put here 2, it is now 1.95 volts, and the output is 11.82 only. Now if I go to 3 volts, here it shows 2.93, nearly 3 volts, but the output still remains at minus 11 volts. Why? we say the op amp is now in saturation, because the input voltage is very large multiplied by the gain factor. If it exceeds the supply voltage, which is in this case plus or minus 12 volts, 11.8 is corresponding to the power supply voltage minus 11.8, and therefore it has come to saturation. So if I come to 2 volts also, it is still 20 volts cannot be shown because it is larger than 12 volts that I have applied to the op amp, so it only shows minus 11.82. If I come to 1 volt, then you see I am below the saturation limit, and therefore 1 multiplied by 10 you get 9.76. Therefore I cannot increase the voltage at the input larger than 1.2 volts, because when I multiply 1.2 volts by 10 I get 12 volts, and 12 volts is a maximum that I get from the power supply. Therefore I cannot get any output voltage larger than the power supply voltage. So that is the idea I wanted to explain to you. So you can also see another very important thing. For example, I am again giving 200 millivolt, 0.2 volts, and the output is 2 volts, nearly 1.94. But what is more important is I am applying the red to the input, the black to the ground. That means I am applying positive 200 millivolts, and multiply by 10 I should get minus 2 volts, and you can see there is a minus sign here. This is actually minus 1.95 volts. So all the time whenever I increase the input voltage, the output voltage is always negative. That shows it is an inverting amplifier. The positive voltage is converted into negative voltage. So these 2 points are to be borne in mind.